Assalamu alaikum students. Today in the transfer of heat, we are going to discuss the second mode of transfer of heat, that is convection. In convection, we are going to explain the convection current in fluid is due to the difference in density, and we are going to learn some daily life, everyday examples of convection. Now, what is a convection? Convection is again a mode of transfer of heat that requires a material medium. Any medium is must be needed just to transfer heat through convection. In conduction, the molecules uh, transfer the heat energy, but they do not leave their place. In convection, this molecules takes the heat energy and their kinetic energy increases and they carry heat through larger distances. The molecules leave its place and they carry the energy with them. So convection is already occurs in liquid and gases, not in solids. In solids, they cannot leave their place. So convection can only occur in the liquid and the gas medium, and together we call it in the fluids. So in fluids, that is liquid or gaseous, heat transfer from one place to another inside the system takes place through convection. This mode of transfer of heat requires a material medium. The molecules takes the heat energy and their kinetic energy increases and they carry heat energy through the larger distance. Now, what is the how it is done? We know that the warm when the heat is provided by some source, the the fluid is heated and the warmer portion is less dense and the cooler portion is more dense. So there it the uh, l- less dense portion rises up and the cooler portion sinks down, and that's how the mixing of the um hot and the cold liquid is mixed. That's how. So the heat can transfer from hot liquid to the cold liquid by physical movement of the molecule, and this method of heat transfer is called convection, and it occurs primarily in liquid and gases. Now, convection is heat transfer due to the density difference within the fluid. Now, you can see that when the temperature increases in the presence of heat source, it becomes less dense, it expands. The molecules itself do not get bigger, but the intermolecular distance become large. So it expands, so it become less dense, and the as it moves up and away from the heat source, it cools and become more dense and then sinks. This is how the convection current is formed in liquid, and similarly in air. The air above the sea is colder and more dense, and air above the land is warmer and less dense. The air above the land is less dense, so it rises up, and cooler air from the sea rushes in to take its place, thus forming a convection current. So you can see convection uh, is the transmission of heat through a fluid from the hot to the cold region by circulating movement of the fluid. So when one part of the fluid is heated, it expands, becomes less dense and rises. The surrounding cooler and dense fluid sinks. This produces a circulatory movement of the convection current. So this is what happens when this is the um, particles shown in any material. When it is heated, the particles is spread out, so this become less dense. And what happened is that those who are more dense, they sinks down, and those who are less dense, they rises up. The cooler and more dense fluid sinks through warmer, less dense fluid, and the warmer liquid and gas rises up, and cooler liquid and air gases sinks. So this is how you can see the convection current is formed. This There is a Bunsen burner, and the beaker is filled with the water. When the heat source is provided, the uh, liquid above the heat source, it becomes less dense and it rises up, while on the sides there is a cooler air, cooler water. So the cooler liquid is more dense, so it falls down. So this is how a convection current is formed. So we say that the in convection the difference in densities, uh, that the heat mix due to the difference in the densities. It flows from one part hotter to the colder part due to the movement of its molecules, and they move because of the difference in densities. So what is the mechanism of convection? When the beaker is heated, you can see this is some sort of a color like potential permanganate can be placed in that. So you can actually see the convection current in water. The colored fluid inside show convection. The beaker is heated. The colored fluid inside shows convection, and the liquid and gases expand when they are heated. When they expand and they move faster, and when they expand, they become less dense and it rises up, and the more dense from the side, the more dense liquid that is on the side, it is rises from the middle, and the more dense liquid from the side, it sinks down. So this is how, and in this you can see how the convection current in the gases is formed. Smoldering paper, uh, if you place a smoldering paper over there, the smokes comes inside this box. There is a candle over this tube. So convection current is formed. The air above the candle they become less dense and it rises up, and this this sinks down, and as comparatively, this is more dense, so it sinks down, and when it expands and become less dense it rises up. So in this way a convection current is also formed in gases. So the denser a cold liquid or gas falls into the warmer area. In this way, a convection current formed, and that transfer heat from place to place as it sets up. Convection explains why hot air balloon rises, so why it is often hotter in the loft of the house than downstairs. So this is the mechanism of the convection. Now the application of convection, that is, you can see this is a hand gliders. There, as the land is quickly heats up, so the air above the land is more warmer and it rises up. The hand gliders make use of that hot rising air, and this hot rising air from the ground lifts the hand gliders in the air, and they ride on the air current. Thus this glider takes helps of the convection current that is formed by the air above the land. Or you can see in the car radiator, there is a car has a radiator. The car engines are kept cool by the water jackets. When the water inside that it become heated, it flows into the copper tubes, which include the cooling fans. The this fan uh, causes air to flow past the tubes, and that cools the water, and that cool water is flows down and back. This water cools down, so it sinks and it flows back to the engine. That's how the car radiator keeps the engine of the keeps the controls the temperature of the car's engine and keep it uh, cool. Now, the other examples we can observe is the daily life example is the sea breeze and the land breeze. So, what happened in the sea breeze as the land warm very quickly? It has low specific heat capacity than water, so it is heats up very quickly. So, air above the land is warmer, and warmer air is less dense. It rises up, and when it rises up, the air above the sea is uh, uh, less warmer than the land, so it is more dense. It rushes in to take its place, and that's how. the convection current is formed. And the hot air when rises, it cools down, and it sinks and it become more dense and it sinks again. So this is the mechanism of the sea breeze, and it forms a convection current. Land breeze is during this occurs during the daytime, and during the night time the land become as it heats up quickly. Similarly, it cools down very quickly, so land become cooler than water. So the warm air over the sea rises up, and it cools down and it sinks, uh, and the more cool air that is as this warm air rises up, this cool air from the land, it rushes in and to take its place. So during the night the land breeze blows, and during the day the sea breeze we experiences the sea breeze. So this is how the convection current is formed in land and sea breeze. And you can see in air condition, we always place air conditioned at the top. Why we place it at the top? It is more efficient when we place it at the top, as the warmer air, uh, because of the persons, or the air of the room become warmer, it rises up. When it goes from the air condition, it becomes it cools, and when it cools it become more dense and it falls down. So this is how a convection current, and the whole air in the whole room uh, cools down. Uh, and the similar hot water system also make use of a convection current. This is the cold water tank, and from the cold water tank the water flows and it goes to the boiler, and where it heats up and it becomes less dense and it rises up, and this is the hot water storage tank. From there it is distributed to the different taps, hot water taps, because the hot water rises up become less dense. So this is another daily application, everyday application of convection. And similarly, you can see that in refrigerators, freezer compartment is usually located on the top. The warmer air from the bottom, that is less dense, this floats to the top, and where it the freeze in the freezer compartment it cools down and it become more dense and it sinks. So you can see a convection current also form in the refrigerator. And so as when we are heating a room, the cold air from the outside is denser, just sinks to the bottom, so heater is placed at the bottom. When it goes through the heater, it warms up and it becomes less dense and it rises up. So this is how the cold the current convection current is formed in the room, and the whole room is heated. Similarly, the ventilators are provided in the walls of a room near the ceiling, which helps to keep the room temperature moderate by continuous circulating of air. The air inside the room gets impure and heated due to our breathing. This hot air rises up. You can see this red arrow. This hot air rises up and passed out through the ventilators, thus allowing space for the current of the fresh air that is more dense. It uh, uh, Current of the fresh air from outside window or the door. So the cooler air enters the room through the window or the door, and from the top the ventilator, the warm air uh, is taken out. So this is how a convection current is formed, and we have fresh air inside the room. So this is all about convection. Oh, thank you and Allah Hafiz.